Hi guys, these are our notes from Monday if you were absent or wanted to look back at them. This is our mini unit on systems. So we got a new little notebook so you guys can put your name on the front. Your table of contents is on slide 5. You can fill it in. Slide 6 and 7 are going to be about systems of equations. We're going to be graphing today, and well, one other way. All right, so this little PDF is located on Google Classroom if you want to print it. Otherwise, we're just handwriting them. So make sure you write down your title, notes 2A.4.1, systems of equations. Your essential question you do not have to write down, but it is, how do you solve the systems of equations by graphing? How do you use a table? Or what are the two ways and how do you do them? Okay, so there's two ways we're going to look at to solve. The first one is graphing, and the second one is a table. So under graphing, it's actually really easy if you have, if you're graphing just lines, it's pretty easy. We practice that with our warm-up. But if you're using like a higher level polynomials, you're going to want to use Desmos or something that makes it pretty easy. All you have to do is graph both functions on the same plane and see where they intersect. Graph both functions on the same plane. And see where they intersect. So pretty easy solving by graphing. You graph them on the same plane, see where they intersect. That's how you get your answer. The other way we're going to look at today is using a table. Okay, so the other way that you can solve them is using a table. So when you make tables, your book actually, makes them horizontal. I like to make mine vertical. Okay, so this is what your table would look like. The first column is x, okay? X is your independent variable. You get to choose your own x's. You get to choose the numbers. You could choose from -4 to +4. You could choose, only positives, but usually want to pick some negative, some positive. In order to get your f of x and g of x column, you have to plug in your x values. And this last column, you subtract f of x minus g of x, and your solutions are where you would get 0. I believe there's a similar lesson in Integrated Math 1, so this may look familiar from a couple years ago. But when you get 0 is not the only time that there's a solution. If you have a negative next to a positive, that means that there's another solution there as well. It would just probably be some sort of decimal. But when f of x minus g of x values switch from negative to positive or positive to negative, there will be a solution between the x values. It just means that, your x might not be exactly 3 or exactly 4. It might be 3.2 or something along those lines. Okay, that's all we're going to write down for our notes part. Now we're going to go do some examples. So you're going to need your workbook. This is on your workbook, page 111. So you want to get your workbook. This is page 111. We have 4 examples we're going to do. I'm going to change one of them, but we have 4 examples we're going to do. All right, so the way that it works for graphing is you graph them on the same plane and see where they intersect. So example 1 does it for us, the graphing part. Example 1 says use the graph to estimate the solutions, if any, to the system of equations. So we have 2 equations. We have f of x, which is just this straight line right here, And then we have g of x, which is this probably cubic function because it looks like a cubic equation. And then you get solutions. Your solutions are where your two graphs intersect. So how many solutions do we have? Well, it looks like we hit at 1, 2, 3 different places. So number 1 says determine the number of times they intersect. They intersect 3 times. And then we just have to estimate those points of intersection. I'm going to erase what I got going on here so we can maybe tell a little bit better. I'm going to start from the left and work my way positive. So this one down here, it looks like it hits pretty evenly at -3, -70. So I think that one looks pretty good at -3, -70 for my estimation. -3, -70. This middle one, though, if you notice, this one doesn't hit exactly at a nice little grid mark. So this one we're going to have to do some estimating. I definitely would say that it's less than a half, right? And then this scale is -10, so this would be -5, so it's less than that. So it's less than 0.5, less than -5, or bigger than -5, I guess you could say. So I'm going to estimate that at about, I don't know, 2.5 or 0.25, comma -2. So if you said something a little bit different, that's okay. If you said like 0.3, comma -3, you know, as long as we're kind of close. And the last estimated point, this one looks pretty good. This one would be at 3 for your x and 50 for your y. So this other one is at 3, 50. Okay, so you're estimating, it says right here, just use the graph to estimate the solutions. So we're just doing as best we can for those 3 intersections. All right, so example number 2, in your workbook, they don't actually give you that little grid. On the online book does, I guess, but it says use a graph to estimate the real solutions, if any, to the systems of equations. F of x equals 4x plus 1. That's a line. This is linear. And then this one's g of x is x cubed plus 1. This is a cubic equation. Okay, so we're going to graph them using Desmos, and we will, use a graph to estimate the real solutions, if any, verify that any identified coordinate pairs are solutions. Okay, all right, so on your paper, you're just going to go ahead and draw an XY plane. You guys don't have this little table, that's okay. That line wasn't very good. Okay, so we're going to use Desmos. That is our, preferred graphing calculator. So we're going to use Desmos.com. I have the app right here on my iPad. So when you graph them on Desmos, I already have them here. The red one is 4x plus 1, and the blue one is x cubed plus 1. So we want to see, kind of looks like the one that we just looked at on our example number 1, but you can see they hit 3 times. So it hits at 2, 9, 0, 1, and -2, 7. So we're going to draw a little sketch of this. We already know the answers are 2, 9, 0, 1, -2, 7, but your answers are just where your two graphs intersect. Okay, so on my graph, I had an intersection at, let's see, I'm going to make my intersection, we'll do purple. So my intersections were at 2, 9, so that means you would go right 2 up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, that's all the way at the top of mine. It had an intersection at 0, 1, and I had an intersection at -2, 7. So left 2 and down 7. 2, 4. So one of them was just a straight line. So this was f of x was just a straight line. So I'm just going to connect all those dots. This was f of x. And then we'll do g of x, which was that cubic equation. So the cubic equation looked something like this. And you just make sure that it hits at exactly those 3 points. So my solutions were at 2, 9, 0, 1, and -2, -7. So we got this from our Desmos graphed it for us, right? It does ask you to verify. The way that you verify is you would take your x, so every, ordered pair, you have an x comma y. You would take all of your x's and plug them in for these x's and make sure that for both of them, you plug in the number 2 and you would get out the number 9. So 4 times 2 is 8, 8 plus 1 is 9. Check for this first one. You plug in 2, 2 cubed is 8, 8 plus 1 is 9. Check, it works for this one. And then you would do the same thing with 0, 1. 4 times 0 is 0, 0 plus 1 is check. 0 cubed is 0 plus 1 is 1. Check. Negative 2 times 4, so I'm just plugging it in and just double checking that they both, you plug in negative 2, you get out negative 7. Okay, that's how you can verify. All right, now we're going to do example 3 and 4. I'm going to change example 3. We're going to do number 4 first since they give you the table. And then example 3, you have to create it. So we'll talk about how to create it. All of your homework is going to give you a table. Okay, so example 4 says, the following table shows values for two functions, f of x and g of x. Based on the table, what conclusion can you draw about the solutions to the systems of equations f of x and g of x? So usually I draw my tables going vertical, like I draw x and then y, going vertical downwards. They just have these going horizontal. So you still have x, and then these are both y's, right? So instead of saying y, what you do is you give them names. So you have f of x and g of x. So it's like Frank and George. Okay, so what you do is you're going to subtract your f of x minus g of x. You don't really care so much about what number it is. You just care if it's a positive or negative number. So you're going to subtract negative 10 minus 55. Well, that's going to give you a negative number. That's all I really care about. You're going to subtract negative 7 minus 25. That would give you a negative number. Negative 4 minus 11. That would give you a negative number. So I don't really care exactly what number it is. All I care about if it's positive, negative, or 0. Negative 1 minus 7, that's also negative. 2 minus 7 would be negative. 5 minus 5, that would be 0. 8 minus a negative 5, well, when you subtract a negative, that's going to turn to a plus. So 8 plus 5 is positive. 11 minus a negative 29, that would end up turning positive, so that would give me positive. And 14 minus a negative, that would turn positive, so that would give me a positive. So what you look for is you look for when you get a 0. This right here tells you that this is a solution, okay? So if you get 0, that means you have a solution, okay? The solution is always x comma y. Well, the x portion of this little table for this problem, the x was the number, oops, my page scrolled. X for this problem was the number 1 right here. So it'd be 1 comma. And then the 5s, I know I have like writing all over it and highlighting and circling, but the y was both f and g were the same number. They were both 5. So you have a solution at 1 comma 5. So the problem said, what conclusion can you draw? There's one solution. It's at 1 comma 5. Oh, well, I mean, I could have checked to see if there was other solutions. The way that you would tell if there were other solutions would be if right next to each other, you would have a negative next to a positive. And the reason why is if you're on a number line, here's 0, this side's positive, this side's negative. So if you have a negative next to a positive, then somewhere to go from negative to positive or from positive to negative, you would have to go over the 0 to get between the two. So notice over here how it says, how it says negative 0 positive, because to switch between positive and negative, you would have to go through 0. So if you ever have a negative and a positive right next to each other, that's also a signal that you have a solution. So I'm going to change example 3 just a little bit, okay? So we're going to change what the problems are. It says create a table to approximate the real solutions, if any, to the system. We're just going to change what f of x and g of x are. That was an absolute value in a fourth power function, and we're just going to try to make them a little bit easier. We're going to do f of x is x plus 2, so that's just a line. And then we're going to do g of x is x squared minus 1. That's a quadratic, so a line in a parabola. So when we create a table of values, I'm going to make this one vertical. Our example number 4 was horizontal. I'm going to make mine vertical. We have x, f of x, g of x, and then we're going to subtract f of x minus g of x. So that's what I did down here. This one right here was f of x minus g of x. That's what that little line was. So we don't really care exactly what number it is. We care if it's positive, negative, or 0. So normally we go from -4 to +4. I honestly don't have a whole lot of room. I'm going to go from -3 to +3 only because I don't have a lot of room. But if we were doing this on like a normal piece of paper, maybe I would have done -4 to +4. Okay, so what we're going to do is we're going to take all of these numbers, -3, -2, -1, 0, 1, 2, and 3, and I'm going to plug them all in for x in f of x. So -3 plus 2, that's -1. -2 plus 2, that's 0. -1 plus 2, that's 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 4 is 5. So I just took them all and I plugged them in where the x was. Now I'm going to take them all and I'm going to plug them into g of x, which is x squared minus 1. So -3 squared is positive 9. 9 minus 1 is 8. Then I'm going to plug in -2. -2 squared is, I'm doing mental math here, talking it out. -2 squared is 4. 4 minus 1 is 3. -1 squared is positive 1, and 1 minus 1 is 0. 0 squared is 0. 0 minus 1 is -1. 1 squared is 1. 1 minus 0 is 0. 2 squared is 4. 4 minus 1 is 3. And then 3 squared is 9. 9 minus 1 is 8. So I plugged all of these numbers over here into f for x and into g for x, and I solved them. So what we want now in this last column, f of x minus g of x, we don't really care so much if it's positive, I'm sorry, exactly what number it is. We just care is it positive, negative, or 0. So -1 minus 8, well, that would just be a negative number. 0 minus 3, that would be a negative number. 1 minus 0, 1 minus 0 would be positive. 2 minus a -1 would be positive. 3 minus 0 is positive. 4 minus 3 is positive. 5 minus 8. 5 minus 8 would be negative. So if you notice, when I did this, I didn't get any zeros, right? I didn't get any zeros. So that doesn't mean, though, that I don't have any solutions. If you see right here, this one, this little level right here, I have a negative next to a positive. That signifies a solution. Anytime you have a negative next to a positive, that signals that there's a solution there. I have another one down here. I have a positive and then a negative right next to each other. So that means that there's some sort of solution. So what we can say to approximate the answers, we're going to say there's two solutions. Those two solutions, okay, you're going to have between x equals, and then we have one between -2 and -1, and x equals 2 and 3. So I can show you guys on a graph, okay? So that's why the graph is like a really good way, and Desmos would give us like exact answers. We're going to get two solutions when we graph this, where one of them or both of them are going to be decimals. They just don't happen at like an exact point. So when I graph these on Desmos, here's, x plus 2, that's a line. Then we have x squared minus 1. So notice how they hit twice, but the points that they hit at are decimals. 2.3 for your x. Oops, I can't write on here. 2.3 for your x and -1.3. So it was 2.3, which is in between these two, and negative, what was it? Negative 1.3, 2.3 and -1.3. So -1.3 is in between -2 and -1. So that's how, those answers are decimals. From the table, we can't see them exactly. Okay, that's why the graph's a good option. All right, so for your homework tonight, they're going to give you a few problems where it is graphed already. So you just have to look at the points and estimate them. If they don't happen at an exact point, you might have to, give a decimal approximation. You're going to have a few problems where you have to graph them yourself, like example 2, so you're going to want to use Desmos, and then you're going to have some that give you a table like number 4. So you don't have to create your own table like number 3. They will give you a table like example 4. So where these notes go, the notes part are going to go on slide number 6 on the right-hand side. There wasn't that many notes, so you don't have to put any on the left-hand side. And then your example number 1, the page 111 goes on slide 7, and page 112 goes on the right-hand side of slide 7. Okay? And then you guys can go do your homework. All right, thanks.